Okay, in this lesson, we're going to be working with optimizing a function, as you can see on top. This specific lesson, we're going to be dealing with maximizing the profit from two different products. Every situation where we are optimizing a function, we're going to be given two different types of functions. We're going to have our objective function and our constraint functions. You'll notice that there's always only one objective function, and there are usually multiple constraint functions. And it's also important to notice that our objective function has an equal sign, and all of our constraint functions have the inequality. So that's a good sign to be able to tell if it is an objective function or a constraint function. So once we have figured out all of our functions, we are going to graph these. And in order to start graphing them, we're going to switch them all into the y equals mx plus b format. These two are already in that format, so we just have to change these ones. Let's do that down here. So we have x plus y is less than or equal to 5. If we subtract x from both sides, we have y is less than or equal to 5 minus x. And then our second one, we have x plus 2y is less than or equal to 8. So if we subtract x, we have 2y is less than or equal to 8 minus x, then divide by 2. We have 8 divided by 2 is 4. And then x divided by 2, we're going to do minus 1/2 x so that we can see our slope factor. So we have a negative 1/2 as our slope for this function. Okay, so now we just need to graph them. So our x is greater than or equal to 0. We're just going to draw the lines for right now. This is going to be our y. And then our y is less than or equal to 5 minus x. We have a y-intercept of 5 and a slope of -1. So we're going to go down 1 over 1, down 1 over 1. There's our line, and then y is less than or equal to 4 minus 1/2 x. So we have a y-intercept of 4 and a slope of -1/2. So we're going to go down 1 over 2, down 1 over 2. We're going to get something that looks like this. So that's a very poorly drawn line. Okay. So now since these are inequalities, we do have to do the shading. So for the y is less than or equal to 5 minus x, since it's less than, we're going to go left side. That's going to be all of this. And then our y is less than or equal to 4 minus 1/2 x. That's this line right here. I'm going to switch to green for this line. We're going to shade in all of this. And then our x is greater than or equal to 0. That's just going to be everything above the x-axis since it's greater than, and y is greater than 0. That's going to be everything to the right of the y-axis. Okay. So this looks like a disaster. There's not much to be seen here, but the only area of overlap is going to be in this area right here. All 4 of these lines, when shaded, fill in that whole rectangle right there. So I'm going to try to erase all this extra stuff so that you can see it a little bit better. All right, there you go. We have somewhat 4 sides right here. Okay. Now we have 4 different points on this shape. Let's figure out what the vertices are for all of them. So this one, this is the origin, so we're going to have 0, 0. This one, we're just going to guess our x is, if I would have drawn this better, it probably would have lined up perfectly, but yeah, that's fine. We'll just say 4.5, y 0. this one right here, we have x is 0, y is 4. And then let's guess this one is about x is 1.9, y is 3. When you are actually doing this problem in the lesson, there will be a way to figure out what all of these points are. Just because it's faster, we'll do it this way for now. Okay, so now what we're going to do is we're going to take these 4 points. We've used our constraint functions in creating this graph, but we have not used our objective function. So we're going to take those 4 points and we're going to plug them in for x and y. So let's do that for all of these. So 0, 0, p is equal to 0 plus 3 times 0, and that's equal to 0. With 4.50, p is equal to 4.5 plus 3 times 0, and that is 4.5. With 1.9 and 3, p is equal to 1.9 plus 3 times 3. 3 times 3 is 9, plus 1.9 is going to give us 10.9. And for our final one, we have 0, 4. 3 times 4 is 12, plus 0 is 12. Okay. So if we were asking for, in this situation, if we had context behind it, if we were asking for the greatest number or the maximum possibility with these 4 constraint functions, that would be this one right here. So whatever our context is, we would have 0 of the x's and 4 of the y's, and that would give us the highest product. If we were looking for the least amount of money for whatever reason, or the least amount of something, that would be this one right here. Which in a lot of situations, it's going to be the 0, 0, but there are some situations where that one is not the right answer. And that's usually going to be if this is negative. And then yeah, these 2 middle ones, you probably won't be using those ones that often just because they are neither the minimum or the maximum. Okay, this will make a little bit more sense as you're working through the lesson with the actual story behind it, but this is going to be your general guideline for how to work through that problem.